sometimes what we want to do is determine the transformations that take one function to another. There's a couple of ways of doing this, and one is by inspection. So let's have a look at an example here to begin with and see how it goes. So find a sequence of transformations which takes this graph, y equals x take 2 all squared take 4, to this graph, y equals x squared. And what you can see is that this graph here simply moves 2 to the left and 4 units up. They are the transformations. So we're going to say that it is a translation 2 units left and a translation 4 units up. All right, but what if we didn't know that? What if you just weren't sure by looking at that graph what it was going to be? Well, here's our technique that we use in terms of mapping. So what I'm going to say is I write the words from y equals x take 2 all squared take 4 to y equals x squared. All right, now this is our original and this is the image of the original. So this is what we've got and this is what I want to take it to. So with the image, what I do is I put in my dashes. All right, now what I do is I call this part of the process pairing up the x's and y's. Okay, so what we've got to get this ready to do is to pair them up. Right, so I'm just going to manipulate this one a little bit by writing this as y plus 4 equals x take 2 all squared. And now we're ready to pair these up. All right, so what I'm going to do is pair the y with the y dash with a y plus 4. So I'm going to say that y dash equals y plus 4. And x take 2 is equal to x dash. So that thing there being squared is equal to that thing there being squared. All right, now what I want to do is I want to state the transformations. So here's an important step in this process. All right, x comma y maps to x dash and y dash. And in here will be the transformations that take place to convert it to its image. Essentially, what this tells us to do is we need to make x dash the subject over here to put in the transformation. And it is, it's already the subject. So we're going to say x dash is x take 2. So I'm going to write x take 2. And we need y dash the subject. And in here is going to be the transformation. Here it is, y plus 4. And now what we would do is read this mapping as the transformations that occur to take these original points here to the images. So we're going to say that this mapping says translation 2 units left, and this one here is a translation to 4 units, I did it again, up. Right, and do you notice something? That is the same as that, and that is the same as that. So by inspection we can do it, but another way to do it is to get the mapping to, I call it serving it up on a silver platter. Now, why would you do that when it's just so easy? Well, baby steps, my friends. All right, so here's another one here. Find a sequence of transformations which takes y equals 4 over x plus 2 all squared plus 5 to this graph here. Now, see if you can do it without mapping. Okay, see if you can do it by recognition. All right, so what I want you to do is pause the video and try to do this problem and write down what you think the transformations to this would be to make that function there. All right, now that you've got yours written down, what we're going to do is actually get the mapping to do this for us. So I write the words from y equals 4 over x plus 2 all squared plus 5 to y equals 1 over x squared. All right, so I'm going to get this ready for pairing, and I'm also going to note that this is my image. So I'll put my dashes in. All right, so I'm going to do y take 5 over 4 equals 1 over x plus 2 all squared. Now, what have I done here? I've subtracted 5 and I've divided by 4 to get it kind of ready for pairing, to get it so that it looks in the same form. All right, so now it's ready for pairing when I write y dash equals y take 5 on 4. Now I'm going to write x dash, so y pairs up with this thing here, and x pairs up with this, equals x plus 2. All right, now let's write our mapping out, x dash, y dash. All right, and it's already the subject, so we're going to write x plus 2 there, and y take 5 on 4. Okay, what are the transformations? Now we can write them down. So I'm going to put this in here, so running out of space very quickly. So I'm going to address the x transformations first. So this is a translation, 2 units, right? Okay, what happens to y first of all? Well, you've got to think about how it's been built up. It has 5 units removed from it. So we're going to say translation 5 units down. And this then gets multiplied by 1/4. So we're going to say it's a dilation 1/4. Now we're multiplying by y, so that's a dilation factor quarter from x axis. I wonder if you got that correct, okay? But if you didn't, or you weren't 100% sure, look at what the mapping does. It just feeds it out to it. All you have to do is read this mapping off here, and you'll get the transformations. All right, here's another one here. What we're going to do is take this function to this function. All right, and again, what I'd love you to do is to try and work this one out via recognition, first of all. And I'd be really surprised if you get this right. I'll be impressed, but I'll be surprised. So pause the video now and work out or state what you think the transformations are. Okay, so let's get mapping to do this one for us. Y equals 3x take 2 cubed take 5. So we're going from this to y equals x cubed. I'm going to throw some dashes in there to indicate that that's the image of the original. All right, let's get it ready for pairing. So I've got y plus 5 equals 3x take 2 cubed to this function here. So now we're ready to pair them off. I've got y dash equals y plus 5 and x dash equals 3x take 2. Let's write up the mapping. All right, so y dash is y plus 5, x dash equals 3x take 2. All right, let's state the transformations. So let's address x first. It's a dilation factor 3 in, or from rather, dilation factor 3 from y axis. That's that multiplied by 3. So multiplying by a factor of 3 by the x value is a dilation from y. This is a translation, 2 units to the left. And finally, another translation, 5 units up. All right, and again, I'd be impressed if you got that one correct. Okay, if you did, well done. All right, what we've got here is a situation where we're taking a function here, sending it to another function, but we're not sending it back to its basic form. We're going to send, this is what I call an example of ugly, ugly. All right, we're going from ugly or transform function to ugly or transform function. All right, this one here, I call this ugly, pretty, or basic. Okay, so we're going from ugly to pretty or ugly to basic. All right, so that's what we're doing in this instance here. And these examples are all examples of ugly to pretty, okay, going from transformed back to basic. All right, and there's another one here that's not actually in the notes that is when we go from pretty to ugly. All right, and I might actually do an example of that so you can slap that in your notes as well. All right, anyway, here we go. So what we're going to do is go and write from y equals root x take 2 plus 3 to y dash equals root negative x dash take 6. All right, let's get these ready to pair up. Y take 3 equals root x take 2. And this one here is going to be y dash plus 6 equals root negative x dash. All right, so now what we're going to do is pair the y's. So y take 3 equals y dash plus 6. And notice that because we're going from ugly to ugly, the algebra comes out a little bit differently. X take 2 pairs with negative x dash. All right, so to state the transformations, what we need is x dash and y dash as a subject, because that's where the transformations come out. So I need to make y dash the subject here, so it's going to be y dash equals y take 9, and I need to make x dash the subject here, so I'm going to say x dash is equal to 2 take x. All right, so let's write up this one here. So I'm going to say that this is negative x plus 2, comma, and this is y take 9. Okay, now all I do is I just read off the transformations. So I start with x and go reflection in. Now, negative x means reflection in y. Reflection in y axis, translation, 2 units right, and this is a translation, 9 units down. Okay, so I've actually added one more example to your notes, so can you please copy this one in? Okay, so here's our last example, and this is a variation on the problems above, and this is what I call basic or pretty to ugly. Okay, so we come in as the basic function and leave as this function, and this is again equivalent to me saying to the hairdresser, I've come in looking like this, and I've said, and I show a picture, and I'd be like, whoever, you know, like this is, I'd hold up a picture and go, this is what I want to look like. What would you do to me to make me look like this? i.e., what transformations would I undergo to look like this? And if you think about it, these other variations on that story. So this one here would be the equivalent of me coming in already transformed, like maybe got rid of any grey hairs I've got with black hair, and now I've got like a transformed all black hair, and I want to go to this, like blonde hair. So I'm going from transformed to transformed. Okay, so ugly to ugly, I call that one. Not that I'm calling myself ugly, but you know, that's the way I think of the function, is messed up or ugly. All right, and the last variation here is this one here, which is the ugly to pretty or ugly to basic, which means I've done something here, I've been completely transformed, and you know what? I've come to the realization that I'm not happy with it and I want to go back to normal. So what transformations would you do to get me back to normal? So those are the 3 variations and the only 3 variations possible. So this is the third of the variations of transformation problems. So here goes the process. What I'm going from is this to this. So the ugly is the image. So I go y dash and x dash. All right, let's get these ready to pair up, and the only one I need to manipulate is this. The way I'm going to do that is I'm going to say is y dash plus 5 all over negative 1 equals 1 over 2x plus 1. And let's just pop a squared on there and a squared on there. Okay, because you can't take a hyperbola, truncus and turn it to a hyperbola. So make sure you update that in your notes. All right, so we're going from this to this. Let's pair them up. Y equals y dash plus 5 all over negative 1. Again, many of you guys will divide that by negative 1 and divide that by negative 1. Perfectly appropriate. You're going to get a different state, a set of transformations, and they'll be correct as well, as long as you do the correct algebra. All right, this one here, let's pair them up, and I'm going to say that x is equal to 2x dash plus 1. All right, now I've just got to think about what I make the subject. How do I think about that? Well, what I need to do is I need to make x dash the subject and y dash the subject, because once I do that, I can fill in the transformations. So over here, I've got a bit of work to do. So I'm going to multiply y by negative 1. So that's negative y take 5 equals y dash. And this one here is going to be x take 1 divided by 2 equals x dash. Okay, So now I've got x take 1 over 2, and I've got negative y take 5. Okay, so now the last thing that we need to do is state the transformations simply by reading them off. Okay, so I think about x as the starting point. What's the first thing that happened? It had 1 removed from it, i.e. translation 1 unit to the left. This here then gets multiplied by a half. So we call this a dilation factor half from which axes? Well, we're multiplying by x, so it's changing, doing a dilation from y. Now over to the y's. So the first thing that happens to y is it gets negated, i.e. a reflection in the, and because we're changing y, this is a reflection in the x axis. This negative 5 means we're translating or doing a translation 5 units down. Okay, and we're done. So again, if I wanted to go from basic to ugly, show the hairdresser like the picture of what I want to look like, this is what the hairdresser is going to do to me. Okay, again, to reinforce what we're doing here, if I came into the hairdresser looking like this and said I want to look like this, what are you going to do? These are the steps. This is what they're going to do to me looking like this to get me to look like that. And finally, if I come into the hairdresser looking like this and I want to look like this and I say, what are you going to do to me? This is what the hairdresser is going to do to turn me into this. All right, so the exercise is 7D, questions 1 and 2. And please, girls, even if it doesn't say it, list the sequence, or maybe I shouldn't say the sequence, list a sequence of transformations that you're going to use, because that's what will be expected in 3-4 methods.